Welcome back to my channel, and today we're going together solve the daily LeetCode problem. And so for this problem, we need to find the minimum number of the operations needed to make the integer num equal to 0. And for this problem, we are given some of the conditions. For example, like for each step, we need to choose the integer I in the range from 0 to 60, and then we subtract to the 2 power I plus the num2 from the num1. So in here, like let's say that if we perform like yes, we have some of the examples in here. So for each step, we need to like choose the I for example in here that is 2, and 2 in the second step, and in the last step we choose that is 0. Yeah, so for this problem, we can simplify it as the num1 equal to the x plus the k multiplied by num2. For the k is the number of the operations we need to make, and then so our task is to find the k. However, in here, like we can transform this task into another task. For example, like what if we check every single value of the k from the very beginning, from the 1 to, and then we will increment the k over the time, and then our task will be transformed into the find the x, whether x can be decomposed to the sum of k powers of 2, right? Because in each step we need to find a value of the I, and then like we need to get the 2 power I in each step. So it means that over the k steps, and then we need to decompose the x as the sum of the k powers of 2, right? Okay, so what is the value of the x? So in here, like for the, I will get an example. For example, like in here I have the x equal to 10, and then like in here we can decompose the x by the in the binary form, right? And in this is the most compact form of the 10. And in here, like we can see that if we have only 2 steps, and then somehow like we can express it as the combinations of the powers of 2, right? Okay, so what if I have maybe I perform 3 steps, and then can I do that? Yes, I can do it, because like in here somehow like we can represent the 3 power 2. In here like we can represent as the 2 multiply the 2 power 2, right? And then so we can also, we have the k equal to 3. This is the first approach. The second approach is that like we can decompose the 2 power 1 in the second case. Okay, so in here like we can have another maybe form of representations for this number, and then this is based on the fact that like this is because any kind of the 2 power I can be decomposed as the 2 power I minus 1 with every I greater or equal to 1, right? Okay, so in here like what is the upper bound of the k? So in here like we can see that if we just have the, because like in here in the worst case, and then we always can decompose the 10 as the 1 plus 1 plus 1 plus 1 plus 1, like that. And then it means that like the upper bound of the k would be the 10th, and then it is exactly the value of the given x, right? Okay, so in here, so what is the lower bound for the k? So because like for the binary representation for the x is the most compact form, right? And then like we can base on these observations to find the the lower bound for the k. And then so if we have the upper bound and the lower bound, we always can verify that if the k, if it lies within this range, and then it will satisfy the conditions 1, it means that we can use the k, right? Yeah, so I think that is enough for us to make some of the code to solve this problem. Yeah, so let's say that we will enumerate all of the value of the k from the 1, and then we will have the k equal to 1, and then we just need to get the y2, and in here we just need to, we will need to check that whether we have the x, right? We need to find the x that is equal to num1 minus k by num2, and then when we have the x, what should we do? Okay, so we need to check the first of the observations, right? We need to check the upper bound first, if whether it can satisfy the upper bound. So here if the k greater than x, right, equal is still satisfied, right? And then so in here like we only need to check the if the k greater than x, because like for example if the k in here that is 11, and then in here like we have x that is just the 10th, and then we have no way to represent the 10 to equal the 11, right? So it means that we always can we need the value of the k always smaller or equal than x, right? And other we need to check the lower bound as well. So if the k greater or equal, then the here like we have x dot bit count, right? And then we can return the k, because this k is the smallest value if the previous one does not satisfy, right? And then we need to jump into the current one, and then so here like we just need to get the k is 1. Okay, so I think that's it, right? Okay, I think this is the solutions for us, and of course you still can find a way to optimize this one. And thank you so much for watching my video, because I am on my vacation, so I don't make a lot of the videos recently. So I will go back to the daily LeetCode from problem from the next weekend. Yeah, so again, thank you so much for watching my video, and see you next time.